So what we're looking for is a function whose derivative is 2x plus 3. So let's just call that something. Let's say we'll call it f of x. F of x is equal to 2x plus 3. We need a new function. We'll call it g of x, which we don't know what it is, such that when we take g's derivative, we get f, which is 2x plus 3. So we need to work backward. And the easiest way to do this is to look at each piece, this term and that term, and we need to say what is the antiderivative of this, what is the antiderivative of this. So how do we work backward? Well, the best way for a little polynomial like this is to take each term and say, let's go back a power. So for example, this guy, if we go back a power, so x would go back to x squared. And if we differentiate this, we get 2x. So we know that this guy goes back to x squared because the derivative of x squared is 2x. Now let's look at 3. Its power is x to the 0, so let's increase its power by 1. Okay, and so if we increase its power by 1, we would get x, right? So this would be just 3x. And if we differentiate 3x, take the derivative of it, we get just, oops, I should write this up consistently here, we get just 3. So if we differentiate this, we get just 3, which is what we want. So this looks good right here if I take x squared plus 3x and I find its derivative. We know that that is 2x plus 3. So we worked backward. Now what we should do though, this is one of the derivatives. So there's a whole family of them out there, okay? And what we should say is that g of x is equal to x squared plus 3x plus any constant that we want to put at the end of it. And so this is the overall, this is the family of derivatives where we should say where c is a real number. And that's it. Now the book only asks you for this. It asks you to find an antiderivative. This is all of the antiderivatives. Okay, so we're getting ahead of ourselves a little bit with this right here, but this is where we're going to be going in the future. Okay, not just this. By the way, this guy is this guy when c is equal to 0.